Alright, so here is a video um, about calculating the probability of something occurring, okay? So basically what we have is a population um, with a value that the researchers don't know, but we're told that 75% of people will contract a disease after being exposed, okay? So we actually know the population proportion for this particular problem, and then we're going to compare it to what a researcher might conclude. In this particular case, 50%. Okay, um, and this happens a lot. We may know the population proportion, and we may get a sample that's a lot smaller or a lot larger, and so we want to know, is that due to random variation? Okay, or is it something that we should expect because samples are just going to vary? And because of random variation, sometimes we don't 100% know. Alright, so this video is probably going to be a little longer than most of them, but I want to walk through step by step. And I'm going to use StatCrunch for this particular video. I have some other videos where I use the TI calculator, so I'm happy to have you go over there and look at those and some of those examples from the Statway course. Alright, so let's go ahead and read the problem and then walk through it step by step. Let's say that researchers want to know how likely people exposed to the Ebola virus are of contracting the disease, right? So that was big in the news a while ago when this video was recorded. And so I thought this might be appropriate. Students might care about this. All right. So the researchers don't know this, but Ebola is very contagious, and about 75% of people will contract the disease after being exposed. All right. So like I said, a lot of times we don't know what the actual population proportion is, but here it tells us. Okay. It tells us what the population is, people. All right. And it tells us what the trait is, will contract the disease after being exposed. So this is the who, people, and this is the what, will contract the disease after being exposed. And so that's the definition of the population proportion. Who has this particular trait? And it's 75% are going to get the disease. Okay? A patient 0 is found. Now remember, a patient 0 is an initial case. Maybe he ate some bad food. Maybe he came into contact with an animal. Maybe he got bit by something and it got into his blood. I don't actually know how Ebola starts initially. I just know that when patients get sick, their blood is very contagious. And so he is found to have had contact with 65 people. All right, so he contacted some people and they contacted some people. And so the researchers think there's 65 people altogether. So the 65 people is my sample size. Alright, so my sample size for this particular problem is the 65 people. Alright, so what is the probability that researchers conclude that the virus is only 50% contagious? And I chose 50% contagious because it's like 50-50 chance. You have a 50% chance of not getting the disease, maybe a 50% chance of getting the disease. And it seemed like to me mathematically that would be a breaking point. Now, I am not an expert on contagious diseases or epidemics or, what creates exponential growth. I'm not a bioresearcher, but to me it seemed logical, right? So for the purposes of this problem, what's the probability that researchers conclude that you got a 50-50 chance of getting the disease? Now remember, we know that 75% of people should contract the disease, right? But the researchers don't know that, so they're just wondering if it's 50-50, all right? So what do we need to do? We need to calculate the standard deviation of this sample, all right? So this is huge to understand. Remember, standard deviation measures the variability of a sample. As the sample gets larger, you're going to see less and less variability. Okay, it's going to look more and more like the actual population. Okay, so this 65 people is going to affect the variability. All right. Now, we're going to calculate this standard deviation as a proportion for two reasons. First, all the values are in percents. We've got 75% of the people and 50% contagious. Okay, so percents are a dead giveaway. Why is that red? Let's find out. Oh, it wants some sort of a yeah, I don't need that. Okay. So all the values are percents. All right? So the other thing that you can do, and this is what I tell my students, is this is a yes or no question, okay? The question is, did you contract the disease? Right? The answer is either yes or no. Yes, I have Ebola. No, I don't have Ebola. Okay? So this is the research question. Did you contract the disease? You know, how contagious is it? Will you contract the disease after being exposed? That's a yes or no question. So this is definitely a proportion. All right. So therefore, because this is a proportion, we're going to use the proportion formula. And that's this guy right here, the standard deviation. Now, for all of you who are super sticklers about notation and stuff, I believe this is the standard deviation because we actually have the population proportion. This would be a standard error if we were using a sample proportion up here. Okay, so I am 95% that this is the correct notation here. For those of you who have real stickler teachers for that kind of notation and stuff. So now, what do all these things mean? Well, P is the population proportion. That's the 75% that get the disease. And N is the sample size of 65 people. All right, just for this example. All right, so the P is going to be 0.75 and the N is going to be 65, and that's going to give us our standard deviation. And remember, our standard deviation is the variability for this particular sample size. All right, so how am I going to calculate that? Well, I'm actually going to use StatCrunch. I know this seems weird. You guys are like, how are you going to use StatCrunch for this? Well, it turns out that if you click the data button, alright, so my video is running, causing my computer to run a little slow, and so hopefully this isn't too big of an issue. Alright, and what you can actually do is compute an expression. Alright, so I'm going to click on that. Okay, so what I have now is the ability to compute an expression. And so I'm going to go ahead and build that expression. So I'm going to hit build. Okay, and the function that I need, right? The function that I need is the square root function. So I just clicked on the absolute value function and I'm going to type S, and that's going to take me down to the S's. And so I'm going to kind of scroll down until I get to square root, right? Now, this S actually showed up here. So let's backspace to get rid of that. So I hit backspace to get rid of that. And now I'm going to add the function square root. So now I'm going to take the square root of what? Remember, it's P, and my particular P is 0.75. And then I'm going to take 1 minus 0.75 from that. If you have a different professor, this is the Q value. The 1 minus P is the Q value. And so your formula may say P times Q. I know our book does, but I actually like just dealing with the one variable. Okay? And then I'm going to divide it by our sample size of 65. So this is our actual formula here, right? And so now I'm going to click OK. There it is in the build. And now I'm going to click compute. Oh no. Okay, so this is fun. Let's try this again. Alright, so I actually got an error message while the video was paused, and so I figured it out. So let's try it again. And what it didn't like was the fact that I didn't put a multiplication sign in between the two P values. So I got 0.75. That needed to be times the 1 minus 0.75 and then divided by 65. So if you didn't put that little multiplication in there, it got a little confused. So I put that multiply in there. I click OK. I click compute, and now I've got this brand new column that tells me what I calculated and the actual value of that calculation. So there's my standard deviation right there, and I can see that it's 0.054, okay, rounded to 3 decimal places. And so this tells me that there's about a 5% variability for a sample of size 65 for a population proportion of 75%. Okay, so I'm seeing variability of about 5% between most samples. Okay, so now let's go back. We have that. So then we need to calculate the z-score. All right, and so what we're wondering is how far away is the 50% from the 75% using the standard deviation as our measure of variability. So we saw that samples of size 65 should vary by about 5%. So how far away is the 50% from the 75%? So we're going to use the following formula, the z-score formula, and books are going to be more specific about this, but I find that if you actually think about it as the data point minus the center of your distribution divided by your standard deviation, or standard error, if you want to be a real stickler, you cannot go wrong. Okay, this idea of the formula is true for every z-score, no matter whether you're doing a means or a proportion, or even if you're doing differences in proportions or differences in means. This is going to work like forever. Okay, so this super duper helps us. Now, in this case, the data point that we're interested in is the 50%, and that comes from what is the probability that researchers conclude the virus is only 50% contagious. So we want to see how far away that is from the true center of 75. Because remember, Ebola is very contagious, and about 75% of people will contract the disease after being exposed. So that's our actual center. All right, and then of course we have the standard deviation we calculated from the above formula that we're going to use in here. So I'm going to plug these in, and again I'm going to use StatCrunch. All right, and so I'm going to go over here, and I'm going to go ahead and do data, and I'm going to compute an expression, and now I actually want to build that expression. And so remember, it's the data minus the center divided by the standard deviation. Okay, so the data point that I'm looking for is 0.5. The center that I'm looking for is 0.75. And the standard deviation that I'm looking for, I guess I could probably add that as the division, but I'm actually just going to go ahead and put in 4 decimal places for it. So I'm going to put in 0.0537, okay, and just let it compute that way. If you need to be more exact, the number's right there. Just type in more digits, or maybe do a copy paste thing. All right, but this is how I'm choosing to do it today. I'm going to click OK. I'm going to click compute. Here is the formula that I used, and here is the z-score. Now you'll notice that z-score is negative 4.65. And if you're thinking about the normal distribution, and let's pull that up because that's what we're getting ready to go to now, right? If you go to the normal distribution and you think about the empirical rule, right? Anything from -3 to +3, right, is going to give you 99.7% of the data. So you've really filled in the whole thing. So something that's -4.655 standard deviations away, that's really far away. So we should be thinking that because this is so far away from the center, that it is unlikely that they're going to conclude this. Now, how small? All right, so let's go back. Okay, so we calculated the z-score, so now we can finally use the normal distribution to calculate the area under the curve for values less than 50%. Okay, so 50% only 50% contagious. So only is at maximum 50%. Now, this area is equal to the probability of the researchers concluding that less than 50% of the people will contract the disease, okay, when the center is really 75, okay? So in real life, sometimes we know this information from lots of data collected. Like, Ebola's been around for a really, really long time. Maybe there is an accepted contagious rate, you know? Sometimes things are brand new. That mutation of the flu, like 5 years ago, that was kind of like bird flu or something. That was really new, and people didn't know how contagious it was. And so sometimes we don't know information because we don't have lots of collected data. So later on in this course, and probably any statistics course you take, we're going to talk more about this and which test to use, okay? Preview hour. Are you going to use a hypothesis test or a confidence interval to use when we do and don't know this information? So this is coming later, but they're kind of scaffolding you up, giving you information so that you can work with the normal distribution, so that you can have a better sense of what's going on in these inferential tests later on. All right. So now let's go back to StatCrunch. Here's our normal distribution. Okay. If the mean is 0 and the standard deviation is 1, then our sample is minus 4.65549 away from the center. Now that's not a between, this is just a standard, and we want to know when x is less than how far away? Minus 4.655, just using that 3 decimal places, just because that's what we use. That's what I use in my class as the standard. And we click compute. You can see none of the curve is shaded in. Now I wish I had the ability to change the scale on the bottom, but unfortunately I don't. But you can see right here, this is the big thing to notice right here, is that it's 0.000016 away from the center, right? This is the probability, okay? So if you've got tens, hundreds, thousands, 10,000s, 100,000s, million, 10 million, 100 million, only about 162 samples in 100 million samples would be this far away or further, given the center is 75%, okay? So that's not likely. The likelihood that researchers think that the disease is only 50-50 contagious is 162 in 100 million. Okay, so that's not very good. Okay, now let's flip back. Now there is a shortcut. Okay, some of you are thinking, why did you do it that way? Why did you go through this process? Now StatCrunch and your calculator will allow you to skip the Zscore step. Okay. And you can just go straight to the end. I'm going to show you how to do that in a minute. However, in my class, please be aware that it will not work, this shortcut, when we do t-tests later on in the semester. We're actually going to have to calculate the t-score and put it into StatCrunch or the calculator. So really, this is a good habit to get into so you don't forget it or get messed up later on. But the shortcut is a nice way to check your work. If you're feeling comfortable doing the process after a few homework problems, use the shortcut. I don't have any problem with that. Just be aware that the reason I'm teaching you this way is so that you form a good habit for later on in the semester. Okay, does that make sense, I hope? So what you can do instead of calculating the z-score is you can actually go ahead and make the mean, excuse me, 0.75. You can go ahead and make the standard deviation the 0.054, right, that we, I guess we did 3.7 for 4 decimal places, right, that we got from up here, okay, and you can put in the p-value less than 0.5 and then compute, okay. And so now it'll actually give you the 0.75, right? And then the 0.696 is going to be one standard deviation, two standard deviations, three standard deviations. So you can see that it's more than three standard deviations away, and it gives you the exact same value. And so this is a nice way of doing it, checking your work. It's a nice way of seeing the actual distribution of your data. This curve right here is one that we draw in class. I'm going to have my students look at. I think it's a great way of visualizing what's going on. My one complaint about StatCrunch is you can't extend those more than three standard deviations away, and sometimes that would be nice. Okay, so this concludes our video. Alright, so the answer to the question is, what is the probability that researchers conclude that the virus is only 50% contagious? The answer to that question is exactly 0.000000162. Alright, and then you can write any sort of conclusion you want from that. I really hope you found this video helpful, because that makes me happy, and I will make another video very soon. Bye.